Hello everyone, and welcome to another Cloud Lunch and Learn session. Well, lunch depends where you are. It may be dinner time or breakfast, but independently on that, the main point is I hope you are enjoying some good foods and you are ready to learn another great session with another great speaker. This time, we have Surbi with us that will tell us all about Snowflake and SQL Server. Without further ado, I'm going to bring Surbi with us. Hello, Surbi. How are you doing?
Hi, Hugo. I'm doing good. Thank you. How about you? I know there is a little
Perfect.
lag.
Thank you very
Yeah.
much for your availability to be here.
Yep.
Wait, sorry, there is a bit of delay. I apologize. I didn't want to interrupt. I just want to say thank you very much for your availability to be here with us and share your knowledge with us. And without further ado, if you are happy, I can enable your screen sharing, and then the stage is all yours.
Thank you. Let's get going.
Okay, all good. Thank you very much. And for everyone, enjoy the session and feel free to also share with us where are you connecting from and what great food are you enjoying. Okay. I still need to collect mine anyway, but let's enjoy the session.
Thanks, Hugo. Thanks, everyone. Hello, everyone. My name is Surabhi Pokarna. I'll be talking about let's look at Snowflake and how it compares to SQL Server. I'm assuming many of you guys are SQL Server professional. You might want to learn Snowflake or you might already know a little bit. And this is the session where when you know one relational engine and you're looking at that another the buzzword Snowflake, and then automatically behind the scene you would be comparing, oh, okay, this is how it is in SQL Server, how it is in Snowflake. So during the journey we would keep comparing, and also we will be using some of the terminologies with cloud databases and compare with on-prem. So here we are, and before we get going, a quick introduction about me. I'm a data professional with 20 plus years of experience. Currently, I'm engaged with enterprise scale cloud data migrations and also leading a global cloud data platform services team. I am one of the board of directors for New England SQL Server User Group in Boston. I speak in user groups, Path Summit, and Data Saturdays. Here is my contact information. If you have any question after this session, please feel free to shoot me a message on your email. So, Snowflake considerations. How would be the flow? Let's set up the expectations. Let's understand the agenda. There are various layers, there are various considerations. This session is about just building that foundation of knowledge for you from the Snowflake perspective. And then with obviously with some comparison. So we start with introduction. What is Snowflake? What is the meaning of a fully managed cloud data platform? How the billing model works, what all are the available editions, and since it's a cloud data platform, we our all browsing in this session we will be focusing via web portal. So how that all that navigation would happen. Then we would move towards the next layer, which is the core. We'll discuss the architecture with the data processing and virtual warehouses. We move towards the actual data layer, database table structure, time travel, data types, loading, unloading, and then some of the performance flavors. And then last but not least, security, governance, and access control, with encryption, and some governance. And throughout this journey, we would be doing some of the SQL Server comparison. So, as you can see, right, this is a very ambitious agenda. And to be honest, we might not be able to cover all these aspects just within this one lunch hour. But objective here is to introduce these are the Snowflake considerations, because in future there would be some more sessions coming from me, more around like just the performance, more just around the security. But this is the foundation where we should understand what is Snowflake and how is the core architecture, and then how we can compare with the SQL Server. So this session type is like sort of 100 level, more introductory session. Moving along, let's stick with the first consideration introduction, which is about how the billing model, edition, and web portal, what all these things work. But before that, if you know, right, I know this is virtual, so I'm not like, oh, raise your hand if you know this and I can't see you, but like, what is Snowflake? Snowflake is cloud data platform, and it is a fully managed cloud data platform. When we go through the demo, we will be reviewing around, we will be looking at the billing model, what all editions and web portal, we will navigate all the options available at the web portal. But before that, what is the meaning of this fully managed cloud data platform? And how you can get going with your own trial version. So we'll be going through that also. So now let's split this, let's start understand first what is fully managed. So fully managed means it is deployed by the vendor. You have no access to underneath operating system or hardware. And you would only go to their website, you will sign up for the services, and then you would deploy based on what all things you need. And all we need is, as a as a professional who wants to actually not only use the offering but actually build your solution, all you need to do is just to log into it. And we, as I said, that there is no access to underlying operating system or hardware when you are running your Snowflake account. And you don't have to worry about all these details around patching or what's ongoing with that component administration. So no component administration required. So basically, we are more directly jumping on building the solution. So now once you sign up for free trial, so free trial is there for 30 days. That's a fair amount of time to understand the offering, understand how you're going to start building your solution. And we will be going through that demo to help you to get going when you want to just get started with your free trial. So that was the meaning of fully managed. Then fully managed cloud data platform. So now when we say cloud, this is a big differentiator for Snowflake. It can run on Microsoft Azure, Amazon Web Services, or Google Cloud. And so basically, Snowflake is cloud agnostic. And currently, at this stage, what my little head and understanding and research shows, Snowflake is one of the unique data warehousing and data mart and data sharing and other platform which is available in the cloud, which is cloud agnostic. And now, when we say you can also replicate, in order to maintain the single source of data, you can replicate the data across multiple region or across multiple cloud providers. So let's say that your data is in Azure and Snowflake, and then you can move that into AWS or Google Cloud, and that all magic can happen with the massive networking capability that is called that is called SnowGrid. But in this session, we are not going to that kind of nitty-gritties of those networking details, but it is giving you the understanding why we say this is a true cloud agnostic cloud data platform and why it is fully managed. Moving along, data platform. So when we say the data platform, that means that it has the functionality available to do anything we need to do to create a data solution. It has the capability to do data warehousing with very rich and robust SQL implementation and compute engine. And we'll come to the compute engine in way more detail. And you can have sometimes, right, like for example, you have, okay, I have my Snowflake, I'm doing a lot of work there, but then we need an extra storage account to move certain amount of data there, and that can be accessed via some other functionality. So you have integrated data lake and various data processing. And then data sharing is the one another aspect. Data sharing is another big differentiator for Snowflake, which makes it stand out compared to other data warehousing solution, where you can build a fully massaged data and sell that on the marketplace on Snowflake, or you have tons of types of data within, like, let's say I work in financial services, so you have various equity data, some kind of data which has come from the various stock exchanges, and your massage data, which is actually talking about the multi-asset, some different kind of analytics you can run, but only a couple of clients you want to sell that kind of data. So then comes the data sharing. Based on the privileges, based on that, whatever the extra financials and legal requirements, once you take care of that piece, you can share that certain piece of data just with a certain type of customers. So this gives you that flexibility not only to build your own data warehouse and data mart and sell those functionalities, but also share the data. Now, with that, let's come to the core. Next 5-10 minutes, what we will be understanding around this core architecture. If anybody has any question, please feel free to shoot that question, and Hugo would read the question and I would be happy to answer. The point being said, we want to make sure that you understand the core. This is the whole objective of this particular discussion. And during this time, with each layer, we will be thinking about SQL Server also and talking a little bit about SQL Server. One of the link which you see on this slide, which is docs.snowflake.com. So when you want to do a little more further of your own knowledge building or study a little more about the topics, this is one of the best knowledge building, like sort of equivalent to the Microsoft Learn about Snowflake, where all the documentation is there. So you can just go and then browse through all the chapters. Everything is there. It's like one of the best resource to learn Snowflake.
Surbi, just quick one. We have here a question. Do you want to address the question now or cover at the end?
Let's see what's the question.
Okay, so the question says, can Snowflake be used as OLTP database? For example, accept inserts, updates, and deletes from an application?
Very good question. So Snowflake, yes, it has an OLTP functionality, which we are not covering in this session. It can address as good as like sort of relational engine with little bit more extra ways of working, which I might not be covering in this one. But short answer to your question is yes, it can do that.
Perfect. Thank you.
Okay. So now here is the Snowflake unique architecture, and it consists of three layers. You can see, right? The data storage, query processing, and the cloud services. Now let's start with the data storage. When your data is loaded into Snowflake, then Snowflake reorganizes that data into its internal, optimized, compressed, and like since it is more data warehousing side, columnar format, and it takes care of storing that data in an optimized manner in the cloud storage. Can you see that? Oh, what is how it is being stored and all that? No, that is being managed by Snowflake itself. So it is managing all the aspect, how data is stored, how it is being organized, file size structure, how the compression is handling, metadata. And some of the metadata I would show you when we will go through the demo. What do I mean? And statistics, because it is everything is internally managed. And some other aspects of data storage and data objects, how they would be stored, and nothing is visible to us as a we are also somewhere in that aligning that even though we are building the data solution, we are also there as one of the different category of user, and we can only access through SQL query operations which we will be running on Snowflake, but we cannot access this underneath data storage layer. Moving along, next layer is query processing. Now let's spend some good time here. uh, Virtual warehouse, I'm like completely taking a step back, right? I'm using like lot of like layman's language. So when we build an environment, let's say that SQL Server in cloud, a VM in IaaS in Azure, some of the cloud terminology I'm going to use, so not on-prem scenario. It's a SQL VM in IIS. Then you would say, okay, or an Azure SQL database, which is serverless. How do we understand the resources in serverless or even on-prem? We understand CPU, memory, disk IOPS, disk throughput. That is how we have been living our life about, okay, how to configure max DOP, how many parallel threads, right? And then how much CPU. So the virtual warehouse is equivalent to compute. Now, what is compute? In the cloud, we call it CPU and memory. That is, and again, I'm using layman's language, so do not quote me that exactly this is how it is. But basically, compute and storage, these are the key aspects from the underneath infrastructure layer. Compute is a sort of combination with that CPU and memory. And the storage is nothing that IOPS, throughput, and then more the latencies with all those combination which we are getting from the storage layer. So in Snowflake, compute and storage is decoupled, which we already see, right? The storage is there and then compute. And compute, the terminology we will be using is virtual warehouse. So do not get confused with warehouse. So there is something related to data. It is more virtual warehouse. But now let's say we are again talking some couple of scenarios. You have a database. In the morning you run a heavy batch, do like what not kind of data insert, data loading, and like larger scale data operation. During the day you run like more small reports, more reading, some maybe some larger reports, but the during the day workload is like more reading and executing some reports. And early morning between let's say 6 to 9 you are dumping tons of data. What you can do, you can allocate two different virtual warehouse. So you can have, like again I'm putting the number which is not the right way to saying, but the thing is if you're SQL Server professional, like I'm creating a compute of let's say 16 CPU and certain amount of RAM, calling it virtual warehouse 1, compute 1, which is actually handling my morning batch workload when I'm doing that large amount of data writing. Or and then during the day I might need like 4 CPU, so I might need the lesser amount of compute, and I create a different virtual warehouse with the lesser compute and that workload which is running the reports. So bottom line is you can assign your compute as to your dedicate your certain amount of compute to that specific workload. So it's not that during the day I do less, I want to pay less and I want to use because I know I'm utilizing less. So why do I go with the larger compute? But in the morning, I need a larger star compute. So you can create multiple warehouses and you can create multiple billing side and see that the various dimensions from the billing perspective also. So this is the place where you have you have the option to create multiple warehouses, virtual warehouses, which is assigned that certain amount of compute to your workload for query processing. Morning batch processing was also called query processing, and then during the day report running was also query processing. So this is the virtual warehouse concept. Any, and you can define by default when you get your free or paid whatever the Snowflake um, get your Snowflake, you have a by default one virtual warehouse assigned to your particular workload, and then you can create more. Any question on this concept? Because I went to that as much layman's language I could have gone just to have that understanding set.
Surbi, so far no question. All good.
Okay, great. Let's get going. So basically, when we talk about the technical terminology around the virtual warehouse or the query processing, so we know that query execution is performed in the processing layer, and this is our middle processing layer. And Snowflake processes queries using the virtual warehouse. Each virtual warehouse is an MPP, massively parallel processing compute cluster. It is composed of internally multiple compute nodes. We would have some diagrams to explain that also. And that is allocated by Snowflake from as a and from a cloud provider. Who is your cloud provider? Azure, AWS, Google Cloud, whatever. And each virtual warehouse is an independent compute cluster that would not share compute with other virtual warehouses. So as a result, each virtual warehouse has no impact on the performance of other virtual warehouse, right? So this was the core concept, because when we go towards the demo, this is what is going to help us to understand how we are progressing and how this entire compute and performance story is built in underneath for us. And when you pay, you know what you're paying for. Third layer, I love this layer, cloud services. So there is matter, like when as a SQL Server DBA, if you are, or a SQL Server data professional, we have a query optimizer, we have statistics, we have tons of metadata, we have users, we have some infrastructure management, and obviously authentication and access control. All that is part of cloud services. Most of these things are managed underneath with the within the Snowflake itself, and then obviously security you are managing, but you can see all that in this layer. So the good thing is now you can think the virtual warehouse, a certain amount of compute which you are paying your hard dollars, and the storage with the for the query processing and then storing the data, that is separate than the cloud services. So that statistics, when Snowflake is managing themselves your database tables of statistics, they are using the resources from the cloud services layer, which you are not neither paying you are, and then nor it is impacting your virtual warehouse performance, which was actually supposed to do the batch work. So this is the very important aspect, but it's like little fine aspect. So it takes some, when you see that in practice, you understand, oh, okay, that is how it is happening. So by default, when you go for your free sign up within the Snowflake, or you get your paid Snowflake edition and account, you would be getting certain databases already created by default with your without even creating your own user database. And you would see that would be giving you actually a lot of views with how the metadata is managed, how the access control, which query executed, and all that, and which we would see in the demo. So these are the three core layers within Snowflake, and this is the core concept from the architecture perspective. Now, the data processing architecture, which was our middle layer, right? I'm just going a little more detail around that before we go towards the Snowflake actual real demo and go through that, what else, Snowflake additions and other things we have. So the Snowflake architecture, which we have already seen, right? And within the data query processing layer or the data processing layer, where we discuss the virtual warehouse, this has three main properties within those virtual warehouses. MPP, massively parallel processing database engine. That means that Snowflake grows its compute power by adding more and more nodes. But it is not something like you will have, like when there is a billing model and other things, you would still be picking up to what node you can go, right? Because it has accordingly things have been built behind the scene for you. So now you can grow, but it is giving you basically flexibility, how you want to grow, up to what level you want to grow for that certain workload. And each node individually you can add, which is more powerful. And it also decoupled compute and storage. Now, decoupling compute and storage, this concept and this understanding, because like in SQL Server, a VM in IS, your compute and storage is not decoupled. But if you move towards Azure SQL Hyperscale serverless database, in hyperscale, compute and storage is decoupled. So you need storage, want more capacity, but not necessarily have to keep adding more compute. So this concept is also very important with respect to the cloud databases. What does this mean when I say compute and storage is decoupled? And that means that you can grow your compute layer even if your data is not growing. And in the same way, we can grow data layer without having to grow your compute consumption. And finally, Snowflake also has a very tight integration with cloud storage. So sometimes, like we have some storage which has already been managed internally, but underneath, obviously, it is Azure, AWS, or Google Cloud Storage, and you want to get along with this mass MPP capabilities and clustered node. You want to get some external storage, then within your cloud provider, in case of Azure or something, you'll have your data lake. But all in all, when you submit a query, all these storage, compute and storage, they would work perfectly aligning with each other, and then they would send the result back. Virtual warehouse operation. Okay, so now remember I said this three things. Let me go back to that particular screen, right? Certain amount type of operations are done by virtual warehouse, but we have a cloud services layer, right? With all the metadata. So what exactly you do when your compute, your dollars or your money which you're spending on would be used? What type of operations are there? Let's understand that, because all other is automatically covered underneath with the cloud services layer. So let's move to on it. I just did a few clicks. Let me go back to this. Yeah. Your select or your data processing, that is one of the thing which is your virtual warehouse in the cluster of compute resources, and it would be used. You're copying tons of data every morning. You are copying certain amount of data from various other external sources, so that would be using your virtual warehouse compute. Then on a routine basis, you have some insert, update, delete, and whatnot DML operations going on. That all is going to use your virtual warehouse compute. Mm. So one of the plural site course with I have copied that link also here, because this table, a consolidated table, there are various other sources, but this is given here in this plural site. I now I just forgot. I have given the credit to that guy. I'm sorry, I just forgot his name. I'm so bad, but yeah. So this credit is given towards the end, and I already spoken with him. So his plural site course. This is the one slide which I have taken, because this slide gives you the consolidated picture from the warehouse sizes with the size and node cluster and credit. So by default, we get an extra small size with your virtual warehouse. But you want to pay more, you want to grow. There is no endlessly that, okay, I want to have a start with a small size, but I would go and then get like up to the 6x large and then pay for those 512 nodes. So that decision is yours, your company's. Even if you know that you have a flexibility to grow up to the certain number of nodes, what is the model which would work for you, that is up to you. And having said that, let's go in with a little demo. Let's browse through. This is the next slide. And let me move to the next screen.
Surbi, quick one before probably you kick off the demo. I just have one more question for you here. This time from Serinkan, that says, when you have a similar query processing every time, does that not create a conflict in identifying which process are running and at what time?
Would you please repeat? If you have a similar query running, say it again, please.
Running processing every time, does it not create a conflict in identifying which process are running at what time?
Yeah. If you have a similar query running, it would give you the complete clarity which virtual warehouse is running that query. If that answers.
Okay, and does not create any kind of conflict besides the fact that the query is similar, right?
Oh, no, it would not create conflict. And that's a very good question. I would show you for a fact that how you assign your virtual warehouse to a certain workload. Then no matter what, sometimes you might be actually losing money or losing that, opportunity to do the little common sense kind of thing within the database engine. But once you assign, it is hooked to that virtual warehouse.
Perfect. All right.
Yeah.
Thank you.
Okay, so before we go and start browsing the Snowflake web portal, how do we start? Let's start with that first introductory screen, right? So you start with the snowflake.com, and then you start with start for free. And then this is the one which I will show you the what all editions are there. So let me quickly fill some of my information. I'm just randomly picking something. Okay, just let's say student United States continue. Okay, these are the Snowflake editions we have. Now with these Snowflake editions, let me just do this one. Our option is Snowflake edition, standard, enterprise, business critical. Then we can pick the cloud provider. Standard is the basic Snowflake edition. So when you are going to go for your 30 days free Snowflake, you are getting up to the $400 free worth of free uses. The standard is the one with a certain features, and I'll come to the difference. But the enterprise is the one with the standard plus 90 days time travel. We'll review some of the time travel, understanding what does this mean. So by default, all your tables when you create within your database, they have a retention of 1 day by default. 1 day means I drop table now and I go and do undrop. That sounds a bit funny, right? Oh, can you do undrop, especially coming from the SQL Server background? You can do that, but by default that 1 day retention is there. You go for enterprise edition, you can change that retention up to 90 days. So up to last 3 months time travel. But that is the by default. But now if you have standard, then that amount of time travel, number of days, that feature time travel is not there in standard. Then multi-cluster warehouse, materialized view, and other things, and more details would be coming in near futures, like little more complex sessions as well. Business critical, you have high availability, enhanced securities, failover, failback, and other options. That is where you would be using the business critical. So these are the three editions available for Snowflake. Then comes the what is the cloud provider you want to pick. So in this cloud provider, we have option Azure, AWS, and Google Cloud. And then within Azure, when we do this get started, let's say that I pick Azure, right? So now remember one thing, when you are picking your regions, try to pick, if you are running all your business in US East, you might have like more edit other than Snowflake, also rest of the other stuff, right? So or whatever, but pick the region where your business is near. You are in US, and then you buy in for your Snowflake, you go and pick some APAC region. Do not do that. And then that is how you get started. So this is the one, your screen number one, that whether you go for your 30 days free trial or you go for the paid one, these are the editions available and these are the cloud providers. And one suggestion, when you pick any cloud provider, pick the region where you would be doing your business. Do not pick something which is not logically connecting the dots. Okay, so once we do that, in my case, I'm like on my paid version because I've outpassed my 30 days free trial. But now let's say that we did that and now here we are. Okay, so this is Snowflake web portal. Let's just navigate a little bit basic. Let's just go click here, there, click there, and then understand that. And then we will go through a couple of exact tasks which we want to do here. When you start your life with your in your web portal in Snowflake, you have certain types of by default roles are there, and you would be granted a certain type of role level access by default. And toward in my slides towards the end, we are covering all this, but since we are doing the demo, let's start our life and start understanding this, how it looks actually. So the account admin, when I create my free or paid subscription, paid account, I'm here as account admin. So account admin means that this particular account, that is the, I can see I have all the visibility, how many databases I create, how many schemas, what's going on, end-to-end account is on me. Org admin, that is much higher level. Let's say you have an organization where you have 4 or 5 types of departments and accounts which are using Snowflake for the various type of data solutions and capabilities. Org admin might be, again, just I'm like picking that thing as an example, might be your CFO who has the org admin access, who can see across all the accounts how the billing is going on, what's going on, how the uses pattern are there. And then might be the something more from the architecture level who wants to see the bigger picture. So that is your org admin. Public is not here by default, but public is like a minimum kind of permission, not much. Security admin, you can create more roles, where custom roles. This sysadmin, do not compare this sysadmin same as our SQL Server sysadmin, right? That sysadmin is account admin. So this sysadmin is within that particular database. You want to have some higher privileges because I have a like I'm account admin. I have 5 databases. Some people few departmental folks, they do not have access to the other side, but they are sysadmin for one or two databases. So you can define those roles. And user admin is the one, I have somebody who is dedicated for creating users, dropping users. So I'm just going to give them the user admin. So these are the default roles which when with your Snowflake account you would be getting, and then obviously you'll be creating multiple more access based on the access requirements and based on your own compliance and security requirements. You'll be creating more custom roles. And this documentation is nothing but the Snowflake documentation which I shared in one of the slide, and this is my like profile ID and all. So by default, when you start your live here, you get this account admin role, and this is your user ID. Now, moving along, worksheets is nothing but like you are running certain, so that from this tutorial 1 2 3 4, by default you will be getting that when you start your Snowflake live. The by default these couple of tutorials are there. The any SQL sample DW scripts is the my script. So when you start your Snowflake live and you are writing some queries, you can within that account admin privileges, and I'll come to this warehouse because by default you're getting this warehouse. You can save these, you like by default all these scripts would be saved, and you want to name them something else, you can do that. Your scripts you want to share with some of your other departmental folks, you can do that. So this is the worksheet, which is more like your work area. I'm currently not going to dashboard because we are not actually building or deploying or browsing through the reports, but in near future sessions with the 200 and 300 level, we'll be going through more in that data. Okay, so ignore this sample DW. I created one database in advance just to show you some of the things which otherwise it takes 45 minutes to reflect a certain type of demo on the screen, and by the time you would be out of this session, but we'll come back to sample DW later on. When you have your Snowflake account, you get two databases by default already created, Snowflake and Snowflake sample data. Snowflake is the data which, remember I explained you the compute, the cloud services layer. This is the one actually running on cloud services layer. Now, this is the database which is actually giving me a lot of information what is going on. So let's see this database, and some of the demos I ran in advance so I can have that data in already built in. Now, what all databases I have? So this database Snowflake is like my uh, is my the 1 minute. Let me go to that little better access history. Okay, it's getting a bit slow, but that's okay. Bear with me a little bit, please. Yeah. So in on-prem setup, if you want to audit certain type of activities, you would enable auditing. In a SQL Server in IS, in a VM in Azure, and that is what I know. You know AWS and other things. Feel free to think from that. Make your assumption and visualization. But here by default, auditing is enabled. All the data, and it is using the compute and storage of that cloud storage layer, not of your own query processing layer, and it is keeping record of all the activities which are happening here. And ignore this compute WH, will come to this one. So this is the access history, and every query gets a query ID and start time, who is the user, like Surbhi did, and then I did like I needed some history to show you guys, so I did like a couple of hours ago some of the demos, and then what all objects I have accessed, and then there are certain queries also. We will go and see what all queries I ran and everything. So this is the access history. What all columns have been during this time, what all columns have been accessed, or how many columns we have currently in our these particular databases. It will give you all the columns and column types. So basically you are getting the idea, right? This is our cloud storage layer, and cloud services, sorry, what I'm saying, cloud services layer, and giving you all that it has views, which is giving you all the details. Moving along, Private sharing, we will come to this piece towards the end because sharing is like a little advanced topic and we'll come towards the end. Then marketplace also will come towards the end. Moving to this activity session. Now, this is the one which I said, right? Any query which I run, it appears here in the query history. And not only that, it appears in the query history. It gives me that how much like compilation time that query execution took, how much execution. So this is giving me all the work which was going on that particular, and all this history, all this data is stored in the cloud services layer in that Snowflake database, and then it is giving you all that information which we are not managing. Copy, if you copy the larger scale data, it can give you that. Task history is one of part of our demo, so we'll come back to that one. Ignore the task history. Now I'm moving to the next section, which is admin. So this is the one. Since I'm account admin, I have full access to this particular section. Let's go to the warehouse. This is what I was trying to tell you. So this is the by default for the your query processing. This warehouse by default, when you create your Snowflake account, you get one built-in by warehouse with the access size. So it is a single node actually. And this particular warehouse, when now just think about that one scenario, right? And we have 15 minutes left. Okay, good. One scenario, you are using this, you are running some statistics, you're running some table maintenance, you're not doing the query processing. And when you do that, you come to this warehouse and you would see status is paused kind of thing. So behind the scene, cloud services did the database maintenance, but your warehouse, which you are paying for compute, is in the paused status because you're not running those. Remember that copy, insert, delete, data loading, any of those queries. So this is the piece which is actually in truly separating those fully managed cloud data platform, those services, and using all your dollars for the real query processing, not for that additional services. So this is the warehouse. Now let's say you want to create one more warehouse, and there was a question, and which I would cover actually in demo also. You want to create one more warehouse for a certain processing. I'm not currently going to do that because obviously it is going on my credit card, but I can give the name, I can define the type, right, which one I want, and I can pick the size, which I showed you, credits and all those hours, and I can pick some advanced option, auto resume, auto suspend. Like in my current by default one, it is auto suspend. And then if you want to create multi-cluster, you can do multi-cluster. And then when I will create a database, I will attach that database with that warehouse. Or when I create a table, even a database is on a different virtual house, a single table, I can dedicate a virtual warehouse to a single table. Up to that much flexibility I get. And we will see that how to do that. Okay, so this is the warehouse which we went through. Users and roles would be like a dedicated, to be honest, you need a dedicated security session around users and role. But I gave you the enough idea, which is you are helping, like you are able to create the picture in your mind. So coming to the, and then security and other things, coming to the cost management, because this is the one where it's giving you my compute warehouse, and then you remember, see, cloud services only, right? So there is zero there, and my compute warehouse based on my work, whatever I have been doing during last couple of days, it is $2.50. And then how much storage we are, like at this stage I have the minimum one, consumption budget, and you can do some monitoring also. You want to have, like, you reach to certain level and then monitor and message me what was going on, you can do like whatnot, and from that perspective. Okay, so now this is the high level idea. Let's go back and go through the databases. I'll create this sample DW database again. I just want to, I'm jumping on one concept because this is the one which actually needs a 45-minute to build the lab, and then you drop, then you lose that lab. So SQL agent, which runs your, what it does, it runs your SQL agent scheduled jobs. In Snowflake, that concept is called scheduled task. Now, assume I have already created a database, and I want, what I want, that every day I want my customer table to be copied as customer one. And that schedule task, create or replace task, I'm creating a task, duplicate customer table, dupe tab. And then that is the one, if you want to run it immediately, you can execute the task. You want to schedule it like that, you can schedule that, like schedule every 5 minutes. You want to have that, suspend that, like disable the SQL agent job, so you can suspend that. So this task, when you do that, how it appears, this is the one demo, and we'll come back to this demo, but the thing is, we might not be able to see all the data, so I want to show you. Task history, this is the tab, all the tasks which you have, right? Like I created one task. This is like equivalent to your SQL agent basically. And it's going to take, yeah. So now, since I have already created the task, duplicate customer table, and it is whatever duration it took and schedule time. And if I want to run it manually, I can run and I can suspend that. And it is giving you this graph also. So this was the one piece which is like I skipped earlier, task history. You can create your task, schedule them, suspend them, resume them, similar to how our SQL agent jobs are there. Okay, but now let's go back and work on that worksheet from the beginning. So I'm going to drop this database sample DW for now. A minute. Uh, no database selected, right? Now, how many databases we have? Let's run. And what I can do, highlight a statement. So whichever statement you want to pick, like show databases. You run show databases. It is currently Snowflake and Snowflake sample data. By default, just the two databases, which with your account you would be getting anyways. Moving along, I want to create my database sample DW, and this is the one which is based on this schema, which in my sample data, Snowflake sample data, which I got by default. I'm copying that schema into my this sample DW database. So this is simple. You just go ahead and create that. So it was going to create your database. So now we have, so when I just run the show databases again, now I have three databases, right? Snowflake DW, which I just now created, and then two default databases. So our database is there. Okay, so what I'm going to do, I'm going to create table customer. So now if you do the show tables currently, let me just write that here 1 minute. So one thing, right, your database context, right? The use database is now sample DW TPCH SF1, which we created. Now let's do the show tables, and let me select this one. What all tables I have? I have none because I have not created any table so far. So now I'm going to go and create this table customer, and which I'm selecting this from that one of the schema on the sample data. So it is copying this table, and customer table got created. So when you do the select star from, sorry, customer, you have whatever the customer might have, couple of thousands of rows. So this is our key table. Very simple, small examples just to build that all the concepts around the basics. So we got a customer table. And what is your, we are talking in the context of sample DW database. You can write use database same as SQL Server. Currently we need not to, it is by default selected. How do you query like top 100 star, like just to give that idea, it is just to familiarize that it is much near T-SQL, how you would be writing queries. And in this case, if I'm doing the top 100 star, it is doing the top 100. And then same, you can do the same different manner, and then you can run the select star from customer limit 100. Schedule task is the one which I just now showed you. If you want to create schedule task, this is how the script, it would create a schedule task. But the schedule task on web, your portal might take some time to reflect. That's why I created in advanced and showed you within that browser how can you see that. I have now, what I did with this schedule task, I got a customer one table, and now all our demos would be around customer one table. So if you run show tables right after this one, let's do that quick one more time. We have, okay, I mean, I have to I created a task, right? I did not actually run it. So I let me run this because otherwise task would run after some time as per the schedule. So now when I do show table, we have two tables, customer and customer one. Okay, fair enough, simple. There is one concept called clone table. So we have 10 minutes left, clone table, and then some of the drop and undrop table. That is the good demo. You have a scenario. There is a problem with the data. Now you have 5 terabyte of one table. You want to clone that table, but you really don't want to have another 5 terabyte of storage and then 5 terabyte of clone table and all that effort. Within Snowflake, there is a concept. It would create a pointer to that table. And when we go back into the slide, we will focus on concept. But currently, let's focus on this demo. So what my task is, I'm creating a table called clone customer. And I'm cloning this customer table. Okay. So we run this script, which is going to do this clone customer. Okay. So clone customer is there. So now when I do the show tables, I have actually clone customer, customer, and customer one. Okay, this is now I have three tables. In customer table, there is a cust key one. What is the data? Okay, cust key one. There is some C name, customer 00001. And then the same story is there with the clone customer also. Underneath, and that is also customer key, customer one. Now, since the clone customer is just the pointer, I can update clone customer because I'm a developer working on some of my internal, like whatever the dirty data or the data correction, and then some kind of want to run some comparison and want to retain this clone customer for some troubleshooting without impacting the customer table. And then when I did this update, now you see the clone customer table that has the C name Surbi because I updated. Just now I ran this query to customer C name where the customer, which is the still the old one, there is it still contains the old customer name. So with this combination, actually we did not create a separate table clone customer, but we are just maintaining two different pointers for the same table with different data. And you can have an entire development department with 2 3 people working with them various type of data types. And then towards the end, then you can come back that, oh, which one I'm going to copy now as my master table, and then you can disregard like all other clones which you created in between. And then couple of slides are there which would actually explain that really good. So this is the one of the concept. My objective here is just throw a lot of few things, keep thinking, oh, how it is different from SQL Server, and then make you aware about what it is. So clone table is one of the cool concept and lot of like utilization of this concept. Now we in with the via our scheduled task we created this table, right? Customer one table, which is equivalent to customer table in terms of data, because we copied all the customer table and now we are calling it customer one, and then it has that everything whatever those many rows. What I want to do here now, I want to drop this customer one table. Okay, so let's drop this table. When you drop this table, now when you run the show tables, you
Surbi,
get, yeah,
you there? Sorry for the interruption. We just have here a user that shared a couple of minutes ago a question, and apparently he needs to leave. And I just wanted to share the question with you before he leaves. He's
sure.
just saying, I'm from a EUC background, such as Citrix, VMware. So we use SQL for server, client, and user database. Can we use a Snowflake instead of SQL Server?
Uh, so I'm not saying you can use Snowflake instead of SQL Server. That's not the objective. But if I may want you to repeat the question, Hugo.
He's just saying that he's from a background of using Citrix and VMware, and I assume they are using SQL Server on premise. So,
Okay,
and
okay,
he's
yeah,
just, yeah.
right, right. So there are a couple of things, right? When to use Snowflake and when to use SQL Server. This objective of this discussion is to make you aware about this. What is Snowflake? What is lying out there? and I work on both the sides. So now you have a trading database, you have a relational engine, you are doing all with your all asset properties, it's super critical, and it's a small database where but lot of critical operation. And then your on-prem setup, then anyways, because Snowflake is only the cloud-based database, you cannot have Snowflake in on-prem first of all. Now, if it is you are running a SQL server in Azure, in ISVM, or somewhere in AWS or whatever, the type of operation SQL Server is doing with the small scale databases, and then how your application is consuming the data with all the application wrappers. You might be refactoring entire application if you end up moving into Snowflake, but now you have within the SQL Server, you have 1 terabyte of database, heavy transactional processing, but out of that you take the data out and you want to build a data warehousing where not only the SQL Server 1 terabyte, you are getting some other sources of data, and now your data is around 30 terabyte. Do not look at the SQL Server to build a data warehouse solution. Take the data from SQL Server, get various other external data from where, and then build your data warehouse here in Snowflake. When we say OLTP, also you can do that in Snowflake, but that OLTP from the backend database, it would be a data virtualization concept which would be playing in Snowflake, because Snowflake is more data warehousing side where you have lot more data. You have OLTP, then you would be using data virtualization concept and using Snowflake, for example. But now who is going to refactor entire application? Because her application is connecting to SQL Server in a certain way. So there are a lot more before you make this decision. But if you have a lot of data and you have large scale reads going on, and when I say a lot of data, like terabytes of data, this and you are already in cloud, then Snowflake is really a worth consideration because it opens a lot more opportunities to work on that data and easily, much less maintenance. You can already see, right, how easy it is to manage the data in the Snowflake versus you worry about all the basics around managing, worry about where this 30 terabyte is going to sit. So journey is yours. You'll be making certain decisions, but this is one option you want to consider, then think about all the application refactoring and lot more. Did I answer your question?
Yeah, I think so. He just claims he understands now, and he said thank you. Yeah.
Okay, no problem. Okay, so moving along, we have 2 minutes left. So now this is how, so what we did, we dropped that table, right? Now I want to show you that piece, which was we picked what is the life of this table. Remember retention time. So retention time, because I have set up 5 days by default with business critical, your retention time is 1 day. It can go up to last 90 days. And this was the one with the retention time. It is giving you the time travel. So what I can do, if my retention is customer one is up to 5 days, I'm just going to undrop this table, customer one. So the table successfully restored. And now when you go back and see the tables, we have now back to three, clone, customer, and customer one. So this was the another concept with the combination of time travel. Now, since we have 1 minute left, I want to just quickly go back to the presentation. Table structure internally is logical structure. It is based on the micro partition. And now how it is there, you can read on the Snowflake website, their documentation, go into more detail. But this micro partition, basically, that is the reason underneath when it is stored in a columnar format with the compressed data, it is able to retrieve the data much faster. And these are the various data types, numeric and string binary and date time, semi-structured and logical, what all things it can store. Clone database table architecture. This is the one which I was trying to explain, that when you have your employee metadata, and let me just do a little less zoom actually. So you have employee E1, E2, E3. These are the couple of tables. And then clone metadata, you did that EC1. And then with the clone table, you can have a pointer to that table, not actually cloning the table with that respect to the data, and it would create a separate micro partition for that clone. and then you can change the data on that one micro partition. Now this is a little bit of like, there's a journey to understand this aspect, but this particular slide, which is already again from the Snowflake documentation, gives you the fair idea underneath micro partitions when you are accessing, and with the clone table, which we already did just now, a clone table, you can actually, without changing the real data, without adding that another 5 terabyte of storage, you can take this use of this feature and use that. Performance monitoring, we did have some idea around each query performance it was showing on our screen. So I'm currently skipping that because that's also would be a big fat session around just the performance monitoring. But there is very less from the performance optimization action side for us as a user or who is deploying the solution. Access control, we already went through these user roles when we started our web portal: account admin, security, sysadmin, public, org admin, etc. And access control comes with its own. If you're a user admin, you can manage all these securables. So this is a lot more similar to SQL Server, to be honest, when you actually end up doing that. So with that, we were able to go through high level all our Snowflake considerations, and we got into the complete grip of the introduction and the architecture part, which was the objective. And we did some of the SQL Server comparison, got look and feel of your web portal, and how the storage and compute is decoupled. With that, thank you so much. This is end of year session. So happy holidays and have a wonderful 2024.
Amazing. Thank you very much, Surbi. That was really informative. I actually have two questions to share with you, if you allow me. The first question probably is for someone with background on Azure, working, building data warehousing. So what are the main difference you would say, or the big difference of using Snowflake or using Synapse Analytics in this case?
Very good question. I know I started my camera. There would be some lag in communication, but yeah, bear with me. So, with Synapse Analytics, when you have there are two big differentiator in my presentation I mentioned, right? One was the data sharing and one was the cloud agnostic. Snowflake is cloud agnostic. You can have your data in Azure, you can maintain the single source of truth, and you can have the seamless integration with AWS and with the Google Cloud using the Snowgrid. That option as of Synapse Analytics is only available in Azure. So that's the one sort of different, like that's where the Snowflake stands out. Second thing is with the Snowflake data sharing, maybe in Azure Snaps Analytics, it's coming in near future, but so far the data sharing also is another big differentiator which makes the Snowflake stand out. So these are the two things. That's why if you're the architect or the one who's sitting on that side, who would analyze what's your requirement and accordingly pick the solution.
Perfect. Thank you very much. One more question. So in a scenario that's clearly one in my mind, one useful feature of Snowflake is the cloud agnostic. So that means you can in scenarios that's companies using multi-cloud or companies moving from one cloud to other can be really useful. But the main question is typically considering that companies have their own data source on different clouds, and considering that you need to integrate those data sources to build the data warehouse in Snowflake. How does it work integrating with Snowflake? Do they have built-in integrations out of the box? And what if there is no integration? Do you need to build the integration by yourself?
Yeah, that's a very good question. That would definitely be in 200 and 300 level talks. We would be covering such kind of more with the demos. Some integration is available. Some integration you may end up building. But you can have those schemas with landing zone so that you actually dump the data, which is easier, right? The bulk insert kind of thing. So you don't have to build huge, different, fancy integration. Create a schema in Snowflake as landing zone, dump the data. And then from there, what all processing you would be doing, you can accordingly plan your data mart, data warehouses, or the data sharing options, and then take from there and then build the next one. But some integrations are available when you check that the data loading and unloading options within the Snowflake and integration, they are there. The SnowPro certification course also has the data unloading and loading module, which talks about those integration as well.
Okay, great. Thank you very much. Well, it's all from my side. It's just two questions that came to my mind. I never worked with Snowflake, to be honest, but by just listening about and learning about it, just two questions that came to into my mind. We don't have any more questions. We have here some people saying thank you. So definitely it was really great session. And from our side, from the Cloud on Channel team side, thank you as well for your contribution and your availability. And before we drop, I just want to say thank you, everyone. Thank you, everyone that are listening to us and watching this session. We Because of you, we were able to deliver this year more than 40 sessions, which is a great achievement. And we, without you, we wouldn't be possible to achieve these numbers. So thank you again. I hope you enjoy and take a well-deserved break and enjoy the time with your family and loved ones. Merry Christmas to you, Happy New Year, and I wish a big 2024 for all of us. And in the meantime, stay well and enjoy the break. We will be back in mid January with more lunch and run sessions because our call journey doesn't end here. It continues in 2024. So, but in the meantime, we need a break. So you deserve. We have every one of us. We all deserve a break and enjoy your break. Okay. And for you, Sarbi, thank you very much. I hope you enjoy your break as well. And let's recharge our batteries to come back in 2024 for more call don't run.
Definitely. Thank you so much, Yuko. Have a good one. Bye. Thanks, everyone. Bye.
Thank you very much. Have a great day.